Today's lesson is on polygons, and the goal is to classify quadrilaterals as well as other polygons. So on your notes page, you've got a chart, and it is not filled in, so make sure you do so, please, as we look at a few different polygons here. So a quadrilateral is a closed polygon with 4 sides. We should know that. Okay, the prefix quad means 4. So quadrilateral, 4 sides. And of those quadrilaterals, they have some distinct characteristics. We have a trapezoid. A trapezoid has exactly 1 pair of parallel sides. And the parallel sign you're going to see a lot is just an arrow that is written or drawn on those parallel sides. So those two are parallel. A parallelogram has 2 pairs of parallel sides. So we've got here, and then to indicate the second pair, I draw 2 arrows on that side. A rhombus, this is a quadrilateral with 4 sides of equal length. The equal length is noted by the little tick marks here. You see 1 tick mark on all 4 sides. That lets you know that all 4 have the same measure. A rectangle is a parallelogram that has 4 right angles. Okay, and we know the right angle symbol that's there. Rectangles also have, as parallelograms, they have 2 pairs of parallel sides. So we can again do this if needed, but we shouldn't because we know rectangles have that characteristic. And then a square. This is a quadrilateral with 4 equal sides and 4 right angles. Here we have other polygons we're looking at in this lesson. So a polygon, closed figure whose sides are line segments that intersect only at their endpoints. Polygons are shapes. Okay? Plain and simple definition, they're shapes. A regular polygon. It's a polygon whose angle measures and side lengths are all the same. So if we think back to our last slide, squares are always regular. All 90-degree angles, all sides, same length. Other polygons could be regular. We'll look at that in a little bit. Then we have this chart. Okay, just some different shapes. We got to know what these are. We have a pentagon that has 5 sides. It's kind of like home plate, those that know baseball and softball, or like a house. We have a hexagon with 6 sides. You know, some fish bowls look like this. Heptagon, much more uncommon, has 7 sides. Certain coins from countries are in this shape, but again, very rare. Then an octagon with 8 sides. Stop signs, good real-life examples of octagons. So, given these drawings, and I know on the note sheet some of the sides are a little cut off, but you guys get the idea here. We're going to name the shape and determine if it is regular. So if you want to pause it, you can. If you want to stay with me, stay with me. This first shape, we see 2 pairs of parallel sides, so it's a parallelogram. However, if we look at our tick marks, see we've got these 2 are the same, but then these 2 are a little different, so it's not regular. Remember, regular has to be all 4 sides, or all sides, excuse me, in this case 4. Our next shape, we have a hexagon. Okay, we have 1, 2, 3, 4, 5, 6 sides. And if we notice, all the angles are the same, indicated by those little arcs that I'm drawing over here. And all the sides have 1 tick mark. So those are, or that is, a regular hexagon. Look at our next shape. We can see we've got 1 pair of parallel sides, which makes it a trapezoid. And we only have 2 sides indicated with the same length. And furthermore, we've got 2 right angles here, but these angles definitely are not right. So it's a non-regular trapezoid. moving down or moving on. We have 2, 3, 4, 5, 6, 7. I skipped a side somewhere. 8. That's an octagon. Look at our differing tick marks, okay? Kind of blurry, but that's 2 marks there. That's 3 marks there. So that is a non-regular octagon. Okay, moving over to the next one's a triangle. And we can tell that it's regular because all our angles and side lengths are the same. So from last unit, we can say it's equilateral as well. And then finally, we've got a parallelogram. And we know we've got equal side lengths there. We have 2 pairs of parallel sides. But the angles are definitely different. We can just tell by looking. That's an acute angle. That's obtuse. So that is a non-regular parallelogram. And this concludes your lesson over polygons.